to another secret live stream. And today, once again, give me a second, there's one thing I have to do. In secret live streams upload, not many people will see the secret live stream because my dear Muricans are sound sleeping. Well, Soda isn't, but Soda should go to sleep because it's late. So just night baking cookies, whatever. I've been craving cookies for this entire day because Soda make cookies. Yes, I just cannot. Chocolate chip, it's the best kind. Alright, so here's what I would like to achieve, goal as my thing, do. So first, let's play some epic music. There we go, that's gaming. Now, here's the thing, here's the pickle, here's the scenario, here's what we're working with today. Here's what I would like to do. First of all, I would like to save this, but for that I'll need to first insert a table with 1, 1, 1, 1, 1, 1, no wait. 1, 1, 1, 1, 1, 2, 3, 4, 5, that's good enough. And then switch it to drag and kind of distribute them all around. So we have the first one, the second, third, fourth, fifth. There we go. And here's the basic idea. Polynomials. I would like to create some polynomials defined by these points, which is so much harder than it seems. First of all, I'll start with an example. I'll start with an example of what I mean. Also, can I save this as the polynomials polyperspective? First, let's have an example, and this will be A. In A, we'll have the first polynomial, the first one, the first, or actually 0 would be better because then it doesn't matter. 0th polynomial, which would be equal to A. A, now, what we need is we need to get the A. How do we get the A? Because that's really simple. See, we have all these points. These points define the polynomial, and here's the basic idea. Don't mind that, that's from a stream. Since these points define the polynomial, we know that for function f of 0, right, the first point, which will indicate with, actually we should with 1, because there's mostly just 1. The first y-coordinate, so the y-coordinate of the first point is equal to A, and that's it. Which means, from this, we know that this is equal to first y, which means first. This is kind of misleading, the fact that there's y underscore 1. Well, this should be more of a y underscore p, because that kind of then makes it more seem like, there we go, p, and then p. And there we go. Now, as you can see, we can move this around, and this point defines the first polynomial. Simple, easy stuff, right? It's perfectly easy. It's trivial, some might even say. Well, we're just warming up, don't you worry, because right now we're going for the second one, which is A plus xb. Here's where the fun begins. We'll have the first, because x is brought to the first power in this one, that's why I'm using first, A1 plus xb1. Let's define them all. And here's where the fun begins. Because this time we will need two equations. We'll need two equations because we have two variables, to set two constants. So we'll have y1 is equal to A plus x1b, and y2 is equal to A plus x1b. Here's where the fun begins. First, let's define A. A is unbelievably simple to define because A is equal to y1 minus x1b, which is brought to the other side. Perfectly fine. B, on the other hand, so we can already, well, yeah, it's fine. We can leave the B in A, by the way. So it can be defined as just y p first minus x p first b. We can just define it like that. It's fine. It's really fine. And right now we can see that as we move it, it does move. But it's the first point. It's defined correctly for the first point. Now it's time to define for a second point where the hiccups start, and you will see why it's so annoying with B. Because you see, for B, we can do the same trick. So basically, first we bring everything onto these sides. We have B is equal to y 2 minus a divided by x2, because this was multiplied by, this is a 2. There we go, festive, and all would be nice and great. We could, we could all live in harmony and enjoy our lives forever. If not for the one little hiccup, that if we do include that, so this is the second one, minus a divided, minus a1 divided by x2. Could all enjoy that, except we have a reference in b, we said equal to something with a, and then a we said is equal to something with b. Which means what we have to do instead is we have to replace that a with what it's equal to. So we have b is equal to y2 minus, and include that, so y1 minus x1b divided by x2. Actually, the simpler way to, because right now we cannot even input that in there because we have a b on both sides. We need b only on one side and one b, without any mess. Now, the simpler way to do it actually would be to start by replacing the a, which basically means y2 is equal to y1 minus x1b plus x2b. And in this case, this is a simpler way to do it, because then we can bring it to the other side, so y2 minus y1 is equal to, and over here, all the trig in the book be outside, so negative x1 plus x2. This is very convenient because then we can just divide both sides by this, which gives us b, which is equal to y2 minus y1 minus x1 plus x2. And now if we input that, it should be correct, I'm hoping. It does seem correct. So, no wait, there we go. And it will be yp minus yp, there we go. This will be the first, this will be the second. And over here we'll have negative xp first. And this already kind of works. There are a couple of positions where it works. I suppose around the, around 1. But then plus xp2. And there we go, look at that, we have it defined with both of these points. How festive is that? Looks wonderful. Now I think you can see why this is fun. Because we then move on to the next one. Another folder, which will be a plus xb plus x squared c. This is festive. f2 of x will be defined as a2 plus x b2 plus x squared c2. We have to add numbers to all of them because otherwise these would be said the same thing, there'll be errors, doesn't matter. And now we can do the exact same thing for all three of them. Festive, let's do it then. So, this time we have three equations. y1, y2 and y3, which are all equal respectively to a plus x1b, x2b, x3b plus x1c, x1 squared c, x2 squared c, and x3 squared c. Can you see why it's fun? This is the one which I solved for the boat fender video. And it's not, honestly, these aren't completely hard, they're all basic maths, there's just a lot of basic maths. So, we start with A, which is very simple because we just move the entire gang on the other side, which gives us A, which is equal to y1. We can actually just bring it on the other side in Desmos already, that'd be good enough, we'll also clean that way. So A would be equal to yp. If I could copy both things, that would be great, but I can't. This minus x x1. Actually, there will be more x's, so I feel like I should copy x. x1 minus x1 squared c2. And this one should be b2. Great. And now we have this bound to a single point. It's time to bind it to more points. Now with b. How do we do it with b? Well, with b, we already know the answer for that. Well, we know the way to do it. We did that. So basically, we bring first we insert what we already know for a, which basically means we create y2 is equal to y1 minus. I feel like this would be easier in Google Docs at this point, because oh my goodness, this is about to get, this is not about it, it's getting messy, and my handwriting won't be more handily, especially since I'm doing with mouse. If I had a kind of cool thing. Oh, by the way, over here I'm pretty certain it's the same thing. I think it is. Great. So we have insert an equation first. Y2 is equal to y1 minus x1b minus x1 squared c. And then we add the rest of the equation. That's a plus x2b plus x2 squared c. There we go. Great. Ain't that great? Ain't that just lovely? And now what we do is we know, the basic drill, which means we just get these b's together and lump them in order to, there we go. And then what we do is we get the b out of this bracket whilst moving everything onto the other side. Oh, this is, by the way, with a negative. Okay, so this is b except plus, oh my goodness, am I not doing that? There we go, plus, and this is with a negative, and this is a b. And then what we do is we bring all of those onto the other side, minus all of this in the bracket, which means we can, let's replace them right away so that they won't get mixed up later on, plus, and the minus, and there we go, festive. And all we have to do is just fraction and divide it by this. There we go. And we got our equation. It looks really similar to the previous one, you might notice. And yeah, that will be a common theme. They will look similar to the previous one if done correctly, because, we're just adding constant to it. So as you can see, a will always be a very simple fix. A will always be a very simple fix because that's just how it works. So let's xp, let's copy that. yp2 minus yp1 plus 1 squared, we can square it because we know the value of that, that's in our table, minus xp second squared c negative x1. We'll see some patterns later on which we'll be able to use in order to actually speed up the process. X, but I first want to make sure these are patterns. There we go. C obviously is not a thing. Instead we have C underscore 2. And right, just like that, we have this defined with 2 points. But we need 3, because this, the minimum number for this is defined with 3 points. This is pretty fun. Alright, so now the last one, which will be 3. C. Y3 is equal to A plus x3b plus x3 squared c. First, let's insert the gang. So we have the b without the a in it, so that's really nice. And then we have the a, which is This one, that's the A. And this one already got too big for the thing. They're festive. Oh, this is pain. So, I mean, the way to do it is algorithmic. It's actually the exact same way as we did that. So, first we bring C's to the end, all of them, which means we also have to bring this part, but this part won't be by itself, because it will be with the divisor. It's not divisors, it's not, that's not what it's called. And then we bring all of those to the other side, minus, in brackets, this. Yeah, and let's replace them with rapid signs, plus, minus. Cool. And now what we do is standard procedure. We take out the C. All of them. C, and then divide the left side by it, actually. So fraction. This is already monster equation. And then C is equal to, let me get my docs back, sick. C is equal to, oh boy, here we go. YP, first of all let me copy XP, because that will speed up process ever so slightly. YP minus YP, and this one will be 3 and this one will be 1. Well, we can do the bottom too actually. So we'll have x3 squared minus x1 squared plus fraction of, that looks like the previous b with squares actually. Is it? Is it previous b with squares? No, it's not, because it has x at the top and the bottom. Squared minus x second squared divided by negative x first plus x second. Actually, it affects things, but first of all, it should be in the negative. When it's going up, it should go the other way, which is not great. That's not a good sign. It usually means I screwed up something. Something is messed up. When we decided to bring that to the other side, that was a plus. Actually, didn't decide to bring that to the other side. We actually just. All right, let's. Also, there is a B, which I just genuinely didn't see. Fudge. There was a B. There's a B. There's a B in there, which we should have replaced with this in this step, which makes it way more complex. Also make this inaccurate, well, accurate but inconvenient, to say the least. And then we have to move all of the C's, so this is a negative C. Cool. Minus this divided by these. Twice. Yeah. Market cannot beat. No, we couldn't stop. I tried. Oh, the last trouble. No, wait. Yeah, it was all the roads we travel. It was back one day. Can't stand memorize this playlist. And negative, negative, positive, negative. Great! Now we're bringing C out of all of those, which means this is just a C. There we go! go! That's what it is. So we have negative p1 squared, yeah, negative, then positive 3 squared. Then we have minus 2. I knew something was up. Okay, it still goes the other way, which ain't a great sign. Negative 1, positive 2, negative 2, positive 1. Okay, let's walk on top then. So, on the top, plus 1 and y minus y, 1 and this one being 2, and divide them by negative first x plus second. Still go this the other way, and I don't like that. That's a really bad sign. Minus, to be fair, over here we have x3. Still, that goes the wrong way. Dang it! Expecting that to change it. And y. Actually, no, it is dependent on the y. y2. Should have been 1 y3 actually. I have no idea why. Doesn't work. 2 minus y 1 of them divided by negative x 1 plus x 2. Something is off. Negative. Now it's kind of correct. And that's what I meant. It's very fun because right now something is off, but I know what. When we're going up, it goes down first of all, so negative positive sign is screwed up somewhere. As it goes up, that's the third point, which means third y. That would suggest that this third y should be in the negative somehow, but it shouldn't. It really should not. Oh, now it goes the correct way. So that's not the problem. Okay, great. The problem is not with y, the problem is with complexity somewhere, somehow. Festive! So we have this. Then what we did is we brought this one, x1. Okay, so then what we did is we moved them. I would really like to break this into one more step. Bring this down. So first of all, what we did is we did this, which means minus in brackets this thing, which causes us to be plus minus and then in division negative 1 squared negative positive 3 squared the ones who stood for something more, we won't forget your names. Wait, is the 2 really accurate? Minus 2. No, it is not. Also, they should be multiplied by x1. So it isn't 2. It is not 2. It is way worse than that. It isn't 2. Actually, it's minus x1 times this plus x3, which means in actuality this shouldn't be minus 2, this, it should be minus x goddamn x crab them 1 and then copy this plus 3. There we go. There we go. Now we have 3 different functions defined based on 3 points. Ain't that festive? It is. It is really fun to play around with. with hard effect to get, though. Alright. Safe. That was 3. Now let's go for 4. As I mentioned, the end goal will be 5. If I have the strength, maybe 6, but I don't think I'll have the strength. XB plus x squared c plus x cubed d. Let's do it. A3 plus x b3 plus x squared c3 plus x cubed d3. Great. So first let's start with A, right? That's right. Here's what we'll have. We'll have equation, and we have y1 is equal to a plus x1 b plus x1 squared c plus x1 cubed d. Let's copy them. 3, 4. And let's replace those with the appropriate numbers. How to target them. Great. Step by step now, right? Yeah. A, which is the simplest one. Bring this to the other side and negate it. So, minus, minus, minus. Cool. Which means A3 is equal to, first of all, XP. Copy that. And then YP1 minus, I know it's a simple thing, but I'll just copy that. XP1 B minus XP1, sorry, B3, I almost forgot. Wait, is it? Oh yeah, it is 3. Then squared C3 minus X1 cubed D3. And just like that, the first point is bound. Now it's time for the second. B. B will be based on this. B will be based on a brainful process. B. So first we copy this into this thing, then we move the B next to the B, then move the rest away, and then we get the we get this, and then we move minus or plus over here, and then we move the entire rest onto the other side, minus this. I could actually just add brackets at this point. Yeah, I will add brackets because the process will kill me at some point. There we go, and now just divide it. How simple is that? Hiding in the Blue, very good one by Hadrat. Look at that! Oh yeah, and we can see the what's it called? Pattern. We are beginning to see the pattern, right? But I don't feel too comfortable using the pattern because it will mislead me, then I'm screwed. XP. There we go. So y p2 minus, in brackets, y p1 minus x1 squared c minus x1 3 d plus x second square c plus x second cube d. Yeah, you can really see the pattern now. And negative x first plus x2. And obviously there is no d, only there is d3 and there is c3. No d. D3, c3. There we go, now we have it bound to 2 points. Cool. I'd even call that sick. Let's see how they... We can get them to overlap. Almost. We could if we wanted. If we just put all of these points on the purple, then they will overlap. There we go. Cool. Now, it's time for the third and fourth. My goodness gracious. This will be grand. So the next one, which is C, may I remind you, the next one will start by copying this, and then we will insert A, and we shall insert B. Now, now what? Well, first of all, now we have to make this smaller, because it don't fit no more. And then the same thing, which means we move everything which doesn't have C in it to the left, and all the C's to the right, because, you know, that's the thing. Doesn't have C, so to the left, has C, great. Now over here we'll have to separate them, which means this one, which will be like this at the end, plus this, and this one, which will be at the end, minus this. And then we'll have to move this entire part out of the equation, like so. This is positive, okay, cool, worth remembering, into this part, which basically means plus x3 this. Well, fraction this divided by negative x1, x2. And once again, we'll have to make that smaller because it doesn't fit anymore. Okay, great. Now what? Is that all the C's? That seems to be all the C's. There is another B though. Great. Another B. I shouldn't do at all the fact that we are now down to the size of 11, which is small. It's tiny. And we have another couple of C's in it. This one will be negative and this one will be positive, and then we'll snatch them right up, and then we will add x1 fraction. Actually, we can just switch them up like this. Dang it, not what I meant. No, just quit that. This and minus this, and then we can set up a negative sign right here, and then we can just get these. Right, this is the same festive. Cool, let's now insert that equation. Oh wait, no, we're not done. I forgot that right now we have to take this minus brackets, insert it on the other side. Excuse me, first I would actually like to copy the equation for the future. And insert that onto the other side with minus brackets. And then take out C out of this entire monstrosity. And it will, I think, fit on the line if we do that actually. Which is great. Actually might not, because we'll have to add... No, wait, it will. It will. Yes. Barely, cause barely, but it will. Great. And now what we do is we actually make it shorter, which is great. Because we just divide this part by this part. And then we just have to copy it into Desmos. Simple. Let's make it a bit larger. Great. Yeah, that's Come on! It's basic stuff, honestly. To be fair, the process is very simple. It's the writing it into decimals part that's killing me. Maybe we could do it directly in decimals, actually. That could work. That would be faster. Alright, but for this one we do kind of need to, unfortunately, do it by hand. Because I don't have anything copied. But we could, yeah, next time we'll do it in decimals, because, my goodness, it will be faster. Minus in brackets, not next to, y1 minus x1 times fraction, times y2 as a fraction, where this would be minus, and in brackets we'll have y and 1, and then save, obviously, first of all, because it's scary, x, and this x would be 1 but cubed, so times d3, which would be plus x second cubed times d3, right? And then we would divide that basically by negative x1 plus x2, simple stuff. And then we would add to that x3 cubed d, subtract from it x first cube d, d3 I should mention, that's important distinction, 3, and then we will add to it x3 with y2, which don't do that to me. Look at that switch. Don't you even dare terrify me like that for absolutely no reason. Divide by what now? Well, y2 divided by, no, wait, minus in brackets y1, it's a y, y1 minus x1 cubed times, let me guess, times d3, yeah, plus x2 cubed times d3, and that divided by the usual negative x1 plus x2, and then all of that divided by negative x1 squared. Yeah, now the lines will start appearing because we are actually because this equation is finally valid, plus x3 times x1 squared divided by, wait, squared minus, this minus is, there's a minus and a plus, I have no idea who to trust. I'm guessing minus x2 squared divided by negative x1 plus x2 plus x3 squared minus x1 times x, oh come on, don't, x1 squared minus x2 squared, both of them divided by negative x1 plus x2. Fudge! Okay, let me, wild guess. This one should be a plus. Wild guess wasn't accurate. They can overlap. Make this a bit. Okay, where did I screw up? And did I screw up over here on the docs? 1 x1 y2 minus y1 minus x1 cubed d plus x2 cubed d divided by negative x1 plus x2 plus x3 cubed d minus x1 cubed d plus x3 times y2 minus, in brackets, y1 minus x1 cubed d3 plus x2 cubed d3 divided by negative x1 plus x2. Festive, now the bottom. And negative x1 squared plus x3 and then x1 cubed. I'm guessing plus, which is not a good thing as well. X2 cube is squared, and if you say divided by negative x plus x second plus x3 squared minus x1 over here, minus on top and bottom. 1, 2 squared, 1 and 2. So none of them are screwed up, which means it's screwed up somewhere around here. Which is great, you know. No, it's fantastic. Okay, we can also examine the behavior of this. So when we move up and down, absolutely nothing happens when something should happen. That's our issue. So there is an issue with y4. No wait, y3. y3 is completely null and void. Why? Okay, why? y3 minus, wait, y3 starts the entire thing. That would mean the bottom is really large and it basically negates the y. I think. Wait, let me actually check. No, because if we negate y, we would also negate the entire thing. Okay, C is definitely switching up the value as we go up and down. It just doesn't really bother the function. Function does not care. So in the third point, if we set y to 3 or 2, oh no, it is affecting the function, just ever so slightly. For some reason, even though the C is changing drastically, because the rest also changing. Maybe that's why, I have no idea. So we have to check over here. As we move further, it goes back. What the? This problem with x3. x3 cubed to d. It's right there. It should be fine. x3 times... Also, there's x3 times this, which is positive, which means after this which should be negative. It ain't though. I'm guessing I didn't switch. Oh no, I divided by them, so yeah, it should be fine. But at the top it should be negative. Is it? Is it top negative? It's negative, yes. Keep them open, trying to keep them. Cause I wish with the kiss. Want you with me with the kiss. Want you with me with the ba da 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 da. right, something's wrong. We have no idea what. It's not the last step. So we have this massive thing. Okay, let's do it step by step in this case though. So the way we start is with, well, first of all, the free equation, right? The third equation, which means we have y3 is equal to x, so a3 plus xp. Okay, so we copied, great. xp3 b3 plus, actually no, there we go, b3, let me also widen this a bit, plus xp 3 c cubed c3 plus 3 cubed d3. Okay, so we start with this. Now what? Well, now what we do is we first start by replacing a with the a. B with the b. And b with the b. Now what we do is we take out the c's, this one which will be a plus, and this one which will be a minus. So then what we do is we take them and we do minus x p 1 times this divided by this. Great, and now what we do is we move all the c's to one place and all the rest to the other. So this one, for example, has no c, so move it to the left. Over here we should take also those c's, which will be like this. It's a minus with a minus, so it will be just a plus. Over here we have a plus with a minus, which will be just a minus. Great, and it will be plus xp3 times this divided by this. This is the beginning. And now we have all those, which apart from the last one, all have c's. Now they do all have c's, which means we can just c3 and bracket them like this, and then remove all the c3s. And now for all of this, oh wait, that was for this thing. Almost screwed up. Alright, all of this we take, we minus in brackets this entire massive part, and then what we do is we take this on the right, the entire bit, cut it, and then insert it as this divided by, and now we take c, so equal c is c3. Wait, is it great? Is it y3? Oh, y3 is another thing. That's right. It's instead it's yp3. I got excited too early. But accurately, it works. Sick. So that's how we have to do it from now on. Great! Now it's time to do the same thing for D. Save too, it's important. YP4 is equal to A3 plus 4B3 plus 4 squared C3 plus we bring the war to them D3. Now what we have to do is we have to insert A. We have to insert A. We could also, you know how we could also do it? We could also do it by replacing, well no, we have to insert A. Then in the A we have to replace, we could also take this and replace like B with that, and that would speed up the process, I suppose. If we, okay, so we can go ahead and first set like this equal to 1 and then something like this, whatever, doesn't matter. The point is, or just keep it there, first if. The point is, that right now it works, which means we can see if it will break. Which means we can basically take this massive thing and replace all the C3s with that. Still working? It is! It is. Fantastic. Now we can take the B and replace all of the B's in here, which is 1, with this. Which still works. That's great, because right now what we can do is we can take this equality, right? We can move the y onto the other side so that we will have negative this. And I'm pretty certain, unless well, I am mistaken, because there are still D's in there. Fudge me! I'll have to... I don't want to solve this one. No, let's control Z a bit. To the simpler one. Alright, great. So we'll have moved this onto the other side with minus this thing. No, wait, we'll keep it on this side actually, because this side is the correct side to keep it on. We just set equal like this. Oh no. Alright, festive. Now here's what we do. Here's what we do now. We take the A, we insert the A. We take the B, we insert the B. Plural. Right now. B's. We take the C, we insert the C's, which should be 5 of them if I'm not mistaken. Or maybe more than 5. There will be, oh my goodness, it's still just as complicated. I forgot about, fudge me. I'm not doing a 5. Fuck no. Like, this is already ridiculous as this. No, there's even more. Great, I enjoy that. I enjoyed that a lot. I enjoyed that fact that you can just... So, revelation, all of this is equal to YP4, in case you were wondering. Taking D out of these would be such a pain. Like, such an absolute... I mean, it's doable. It's only doable. It would be just a pain. So here's what we need to do in order to take out the D. I am not doing a 5. No, I am not doing a 5. I am not doing a 5. No, I'm doing a 4. That's it. Okay, here's how you take out the D out of all of these. It's actually not as bad of a process as it could be. It ain't great, but it's not as bad. So here's how I do it. First, we can do it actually with a... No, let's take back a couple steps. Until we had this... Back to when we had the C's. Okay, that's when we have... Okay, that's before we added the B's. Great. Here's what we gonna do. We gonna, first of all, delete these, because I'm not doing a 5. And then B is fine, right? Just reorganize it ever so slightly in order to get these to the front. For just make it a bit easier. And right away remove the D's from this. So later on I won't be able to. Too much garbage around. So plus XP4 negative. Okay, and then what we do is we paste it, divided by. Oh yeah, no, they also should be negated. So this is not negative, this is negative, and then divided by this. Love it when you hurt me, lo, want you, lo, need you, lo. And this one actually is it's still C3s. Okay. This one has a C, all of them have a constant. This one has nothing. Great, let's move it. Let's move it to the other side. Whatever gets it easy, whatever makes it easier. Minus this. Great! We got one term to the other side. Now only for the rest. Wait, negative X P1 P2. Okay, we can move this to the other side. Also negate these minuses together. Festive. We can move this here. So minus this, but so plus this as a minus divided by this, and also this also minus. That doesn't seem quite right, does it? Even when I'm sleeping. Plus. Yep. But then that would negate together. Doesn't seem quite right either. Oh, because these are multiplied by a different thing. Alright, great. What's the first thing on the list? It's XP1. And over here we would get this minus, so this thing times XP4. There we go, we moved a part of it onto the other side. Now it's time for the rest, and it's also time to fix the D's, if you know what I mean. Let's right away set up the place for the D's to make it at least a bit simpler for myself. There we go, now it's not the same equality, and we just would like to remove the D's and move everything we can in there. So now we need this. Great. We no longer need a minus for this. So then this minus this thing divided by, and whatever, what was there? That's what it was. Sick. This times this, because if I screw it up now, then oh boy, will have some fun time fixing. Great, that's great, except now we have to replace the C's, which I'm not looking forward to it. I could also divide, no, because now I have to divide both sides. Okay, let's insert the C's. That's I don't like that. Ouch. 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 Youch. Me ouch. Me ouch. There we go. We have to get these out of these. As I may call it. We have to get these out of these. How to do it well? How do you go about doing it? Very simple. You see, we just, this has a minus sign on it. Okay, so I should have applied all these minus signs, because otherwise I'm getting lost. Festive. So there's a plus, and then this would be a plus, and then this would be a minus. There we go. Which means all of those would be plus at the end. Yeah, at the end of the thing. Plus. I'm an idiot. I'm such an idiot. I'm such an idiot. I'm such an idiot. Are all the C's still intact? Yes, because this is small. Perfect. I'm such an idiot. I can move the D's first in the C, and then add it in, and then we'll have the D as a separate. That is so much smarter. Okay, so first let's move all the D's separately, which means this entire thing is a minus, which means we have to take this in, then we have to minus it, whatever we are getting out of the thing, and then divide this by this, and over here as a plus. And then whenever we take out, which means, for example, these, let's add a plus to it, and then we'll get a nice minus, minus, plus, plus, minus, minus. And now we can take out the D's. Take out the D's by adding a plus. This divided by this. I'm pretty certain this is just copied, right? 1 cube D, 2 cube D, 2 cube, 1 P1, so 2 and 2 festive. So this plus this the other time, except minus, because why not? And then multiply it by P1 and multiply it by P3. And like if I were to copy all of these, like cut them, and set D3 to 1, would it work? Please tell me it would. It wouldn't. I screwed something up. Or to be more precise, I fucked something up. Which is not good. That ain't great. We'll sing the warrior song. Okay, that's great, that works. So now, let's just dump it somewhere, doesn't matter. The point is this works, and because of that we can manipulate that and check when it will stop working. And when it will stop working, that means it's time to worry. So if we do minus this, out of that divided by this thing, it still works. Yeah, so I was correct about that. Now if we do, this would be minus xp3 divided by this. It doesn't work because I haven't taken out that. There we go, festive. And now we just copy this thing, except with a plus. Really? A plus? Why a plus? Oh, because the plus. Oh, okay, yeah. Plus xp1. No. Big boy letters. xp1. This, which doesn't work, but it will once we do this. Festive with a capital F. Because now we can take them and just add them here, and it works, and we have the D's in a separate place, which is great. But still, these ones will be annoying as they can, but I can still like kind of separate them here. So we'll have this thing, this C, and now when it comes to these C's, we should just do it the exact same way. So we have C like this. Also, it's in case this C, and now this is minus minus, which means a plus. Or actually no, minus and minus. Yeah, let's keep it as a minus and minus. xp4, not 5, we haven't gotten that far. We won't get that far, I refuse. Divide by this. And over here this should be the same thing, right? Yeah, it is. Festive, which means, if I'm not mistaken, plus, because over here we have negative, yeah, plus. And it's 1. Plus xp 1, this. Great, and take them out of the equation. And now we have all of these squared away. No c's around here, no sir. Oh, there's c, whoops. But no c's over here, no sir. Which means we can move them to the other side. But by adding minus this. Great. Now the only thing left to do is just paste them c's and figure it out, hopefully. They all have these in it, right? Yeah, they all have these, which is great, because now if we copy all of that, all of this, if we copy it, if we import this here, then we can actually separate it a bit differently. So like this, and then this one is minus minus plus xp1 squared. And so this one can go the other side as a plus. Okay, so might have a, this one go to the other side as a plus, because minus and minus give us a plus. Great. Plus this. I suppose we have one too many and one too many. That's great. I refuse to think about that even. Alright, now we go back to the left, and what all the C's are at the left? Well, this one is full of these. This is full of these, which basically means we can take this, right, and we can add it to the D. Add, and then remove all the D's. Yeah, and just leave it there. Leave it at that. Alright, cool. No, Ctrl Z. Ctrl Z with that. And it's time to insert another 2 C's, I think. Oh boy, do we have 2 C's in each of those? We could also generalize that, copy it, right? Is it the same thing? 1 squared C3, 2 squared C3. Yeah, we have. Okay, so this is what we'll do. This is what we'll do, because I'll make it simpler. Also this one, in which case we have the left side, which xp4 squared. Is it plus or minus though? xp plus xp4 squared. This times xp4 squared, and then minus this side, which is full of these. There we go, and then we shall remove the d's. Take that in, like this. Great. And now this is the only thing left. It is. It's the only thing left. Okay, great. How about, well, it is all multiplied by c, right? Yeah, it is. because this is the... It is multiplied by c, which means over here we can just add c3. And what's great about that is that we can use the exact same method as we did before, which basically means, first let's copy that. Let's add 3 pluses to know what is this, and keep it as a negative, and then multiply it by this too. And then we can cut this entire part, go to the other side of the equation, and no, just add it there, just throw it in. And now we can go to the left. Remove these 3 pluses. And then this entire thing multiplied by negative dot. So this. There we go. With all the d3s removed. We can cut this part. Then we can just add it to the mix. And now here's the thing. If we take this entire bracket without the starting d, if we take this entire bracket and we take the right side of the equality, and right now we have d3 equal to something. Great. Start the right, go the left. Divided by this. Remove that. Implicit equations of... where's the issue? Implicit. Is it... do I have more than one equality in here? Because that could cause it to break. Anyone sees the issue? D4 is on the other side in the division. Over here, I forgot to take this out of... That could have been a problem. I won't lie. Alright, yeah, now it should be fine. The entire right side. We divide it, let's remove this too, by this. There we go. Fuck, it doesn't work. Aha! I was really expecting... okay. So, I mean, kind of, wait. From my point of view, it suddenly seems as if... What's the issue here exactly? If we move up, it flattens, it flips around this point right here. So I could figure it out, but I feel like I just won't give up because this equation, this is, I mean, look at, okay, A starts off nice and simple, B, yeah, gathering some complexity, C is already a mess, and D, I mean... I am completely fine with this not working at this point. It's been, no, I just, no, messed up so much. I don't care. I don't care. Alright, that'll be it for this stream. I'm so tired. Alright, that'll be it. Thank you so much for watching and have a great day. Oh wait, no, oh wait, it's not trying to check out the secret stream. Oh yeah, I forgot. I don't actually quite end